Hey guys, before we kick this video off, I wanted to give you the prereqs for this installation project. While I was able to run this on an 8th gen Intel i7 processor, it was a catastrophic boat anchor with only 24 gigs of memory and a 1050 Ti video card. As such, you're going to want to run this on at least a 13th gen i7 or the AMD equivalent. While you can run it on slower hardware, it'll be basically unusable outside of just a proof of concept build. As per memory, you want DDR5 32 gigs or more. You're going to want a video card, a GPU with at least GDDR6 and at least 8 gigs in size. Lastly, hard drive matters. You're going to need an NVMe drive and it can't be the SATA type. While you can run this on slower hardware, it would only be a proof of concept on that hardware. All right, subscribers, let's jump into the video. Today's video is going to be how to do a configuration of the Ollama AI hosting system. This is a 100% offline AI system. We're going to build this system on a Ubuntu server, and I'm going to go through the installation, but I'm only going to highlight the 2 changes that are going to be necessary in order for this to work correctly. In other words, everything else that you would set up in the Ubuntu server setup should be the default. The first place you're going to want to change is your configuration for your disk. The reason behind this is because the default configuration in Ubuntu is going to set the root directory to a certain amount of storage on your local disk. Now, unfortunately, I would love to tell you what that storage limit is, but everywhere I've looked has conflicting information. Ubuntu's site indicates it's 20 gig. However, using the default configuration or entire disk has also given me 40 gig or 60 gig depending on the size of the hard drive. My guess is there's some kind of configuration in the Ubuntu server setup that's based on the total storage size, and then a percentage of that size is used for the root directory. The problem is in the Ollama configuration setup, there's no way to change where the LLMs sit. LLM, all it stands for is large language model. This is basically a database of language, meaning that everything that you speak, every sentence, everything that I say in this video technically could be added into an LLM, and then you could use that to look up exactly what I'm saying here. The LLM could be tremendous. I've seen ones as big as 1 terabyte or larger. It's important to keep in mind that when we're doing this installation, we're basing this off of physical hardware, even though I'm shooting it on a VM. You don't want to run this on a VM. In a world of virtualization, AI is not good with virtualized systems unless you're using a cluster or some form of high availability designed for performance redundancy. Otherwise, this should be run on physical hardware. So what you're going to need to do is use the keys on the keyboard to hit the down arrow until you get to custom storage layout, and then use the space bar to select it. Use the down arrow again and choose done. On my particular system, I'm only going to use 120 gigs of total storage. On your physical system, I would suggest no less than 1 terabyte. Using the down arrow, highlight free space and hit enter. When given the option, choose add GPT partition and hit enter. For my partition configuration, I'm going to use 110 of the 120 gigs and then choose create, using ext4 as the format and the mount as just the /. Once you have your partition configured, choose done. Choose continue to write the configuration. The last customization we have to make on the installation of the server is adding the OpenSSH server. This will give us the ability to connect to this from our Mint system, or if you're on Windows, PuTTY. It's going to be very important in the installation process, as there are scripts involved. If you have SSH keys to import, you can do so now. However, it's not necessary. And realistically, for our configuration, all it's going to do is give us a prompt during SSH that'll be similar to when you remote desktop with Windows. Once you've checked off the install of OpenSSH server, use the arrow keys to go to done and hit enter. That's the only 2 customizations you have to do in the installation process. Once the installation completes, reboot the system. When the system comes back up, log in. Now that we have our server up and running, we're going to have to do some maintenance. The first thing we're going to do is update it and then upgrade it, followed by a reboot. If you followed along with any of the Linux Mint videos, then you'll know that the command logic inside of Ubuntu is nearly identical. Since they're all based on Debian, all the commands, for the most part, work across all of the different systems. This means that if you know Linux Mint, you're already a server administrator. To start with, let's update it, which just sudo apt update and hit enter. When prompted, enter your credentials. Next, we're gonna run a package upgrade. You could see on the screen that we have 95 packages that can be upgraded. Something we generally don't do in this community is do combined scripting processes. In other words, tell the system to do one thing and then do another thing. However, it's relatively simple, and I'm gonna show you here now. We're gonna run the command sudo apt upgrade space -y space and then two and symbols, followed by sudo space reboot space now. This combination will upgrade the system to the latest package build and then reboot the system once it's finished. Once you have that entered, as seen on the screen, just hit enter on your keyboard. Once your system is done rebooting, make sure you log back into it. Next, we're going to want to install some prereqs. What we're going to do is we're going to install the ability for us to run an ifconfig on the system, which is specifically the nettools package. To do this is relatively straightforward. It's just sudo apt install net-tools and hit enter. When prompted, enter your credentials and hit enter again. If you're following along and you want to clear out the data in order to keep a clean screen, simply type in clear and hit enter. Obviously, this is up to your discretion. I'm just doing it to make it easier to see. Next, we're going to have to install video drivers. Keep in mind, you could run this package without video drivers, meaning that if you don't have an external video card, it'll still work. It's just a little slower. And the speed of your video card really matters in this type of configuration. So in other words, if you're running like a GDDR3 card on a newer piece of hardware because you don't really do gaming, but you just want to have the video card for additional monitors, skip this step because all it'll do is it will slow you down because DDR5 is faster than GDDR3. Okay guys, so feel free to pause here. At this point, this is your video card configuration. This stuff will already exist on the GenericTechSupport website, so you could go to that website and just follow the project there to grab the commands, the scripts, and everything else. But if it's easier for you to just pause here and grab it off of here, you could do that as well. But to give you how this works is basically what you're going to do is run the command to install your PPA. So if you have an NVIDIA card, an Intel card, or if you're running, an AMD card, that information is on here. Here's the Intel and AMD, so you would just add the PPA repository for whatever graphics card you're running. If you have a mixed configuration like a laptop that you're going to attempt to run this on, then you could obviously run both these PPAs. It doesn't really matter because the way this works is once you have the PPA installed, you'll run a sudo apt update, and then afterwards you'll install the drivers by running the auto install. And the system is smart enough to know which repository to pull the drivers from to install what it needs for your system. This step is going to be critical if you want to use your video drivers on the installation progress because the ollama configuration does include drivers, but for whatever reason, those drivers appear to be outdated. So running this command in this configuration will solve an error that you'll get on the installation of the ollama package itself. In other words, generally what happens is it'll throw an error that the video card is newer than the drivers that were released. But in this situation, if you install the drivers first during the installation, it will actually skip it because the newer version of the driver is already installed. This may vary if you're on a headed system. In other words, if you're just running Ubuntu Desktop or Linux Mint. But I believe on the server, it doesn't install the video drivers by default because all we're looking at is text. Since I'm on a VM here, for the sake of this video, I'm not going to bother with this step because it's not going to work anyway. I can't translate the actual NVIDIA driver config through the VM to my system. So I'm just going to skip this all together and go to the next step. The next step is going to be run ifconfig on the system and figure out what the internal IP address of the server is. Now, if you want to, you could skip this all together and do the full configuration on the server. But I intend to use SSH from a Mint system to access the server just to make my life easier. And the reason why is because my Mint system contains all of my scripts. So that means I could just copy and paste things, which does make life easier. You could use Windows or Linux. I'm going to use Linux for this video, but if you want to use Windows, all you have to do is download PuTTY, and you could use that to do the same thing. To access a system with Linux Mint that you're going to SSH into, for instance, a Ubuntu server, which is what we're working on currently, all you would do is type in SSH space the username, the @ symbol, and then the IP address of the system you're trying to connect to. The username is case sensitive, so if your username has a capital, which it shouldn't, but if it does, then obviously you'll have to put the capital in the username on your setup here. Once you hit the enter key, you're going to get the fingerprint of the actual system. Since we didn't import a key, this is not a trusted fingerprint, which means you're going to have to type in yes to continue here in order for the system to connect. After you type in yes and hit enter, you'll be prompted for the credentials for the server. Keep in mind, you have to physically type out yes and not just hit Y and hit enter. Once you do that, you'll connect. Now I have two different boxes open here. One to show you the local system's name, which is VMTR3EGTS. And then we could see the actual server that we just created, which is GenericTechSupport-AI. So we know that this is connected through SSH to the correct terminal. The first thing we're going to have to do on our server is to create a folder where we could store our scripts. Because by default, the Ubuntu server doesn't necessarily have anything in the home directory, meaning that In a typical system, if we do an ls command, we'll see things like desktop and documents and downloads and pictures and videos, because that's the user profile, because there's a GUI. But on the server, there's no GUI. So if we type in ls here, we're not going to see anything. This means that if I type in ls and I hit enter, there's nothing, which means I'm going to have to create a directory. And in order to do that, I'm going to type in mkdir scripts and hit enter. Now if we type in ls and hit enter, we'll see scripts. That exists inside of the home folder. Next, we're going to change directory to go into scripts. To do that, we're going to do cd, which stands for change directory, do space, and type in the letter S and hit tab. Tab will autofill the rest of the name as to whatever you created. I use scripts. If you use something else, then type the first letter and hit tab. Once you do that, hit enter. The next part of this is we need to create a text document in scripts. Ubuntu Server comes preloaded with Nano. So what we're going to do is we're going to type in nano, N-A-N-O, and hit enter. Nano is a text-based editor that exists in the terminal. Believe it or not, Windows at one point had this, but it's not very popular in the Windows infrastructure any longer. So think of this as something like Notepad++, but in the terminal itself. The thing is since we're SSH'd into the system, we could grab local data and paste it into here, which means that we could easily create and modify scripting or text files or SH files or even Python scripts without ever really having full access to the system or the need to copy data to it in like a UNC path. Since I already have my clipboard copied, all I'm going to do is I'm going to right-click and choose paste. And this is going to paste in my SH or my bash script that I need to run against this system. This is the next step in our process, which is modifying the way the swap file works. This is also going to modify how the swappiness of the file interacts with the system. I think the best way to think about this is imagine having the ability to modify the page file on a Windows system. That would give you the ability to choose what, how long, and how much goes into the page file. And I don't just mean size, I mean, okay, we're going to write data to the memory. Then once that data is written to the memory, do we want to write it to disk or do we want to just flush it and dump it? In Windows, there's really no way to do that. You could shut off the page file completely, but it's still going to allocate a couple megs anyway of page file. But in Linux, you can. You could tell the system to not write the stuff to the swap file, to keep the memory volatile in the physical memory. And when that memory runs out or exhausts, it'll dump the memory, because there's a certain time period or threshold that it'll hold onto it in physical RAM before it either flushes it or writes it to the actual cache, which is the swap file. Since AI is such an enormous entity and requires so much memory to run, I decided that the easiest way for me to fight the limitations of my system resources was to adjust how much system resources is allocated, and then what do we do with that system resource after we're done? The thing about it is that you have to modify not only this file, but once you get the entire AI system built, you'll have to modify how long you retain the data in the AI. Because if you set it to a lower threshold than what we have here in the swap file configuration, then you can actually clear memory faster than you use it, which means that you can actually get performance out of a system that's not quite as fast as the hardware requirements to run AI require. So let's talk about what you need to modify in this script, which is pretty simple. All we'll have to do is actually modify the amount of memory that we're using for the actual swap file. Now, since the minimum you should use for a configuration of physical memory is 32 gigs for an AI build, you would want to set this to 32 gigs for swap file size. But that number is static, meaning that if you have 64 gigs of memory, you still want to use 32 gigs of swap file. If you have 128 gigs of memory, you want to use 32 gigs of swap file, basically making that the ceiling for the size of the swap file. So in this configuration, this is a do as I say, not as I do, because again, since we're running this in a VM, I'm not going to allocate that much as far as resources is concerned, because the system won't see the light of day after this video is released. So now that we have this configured the way we need it configured for our particular setup, you know what you need to allocate as far as your system is concerned, and you know the purpose of this script, we need to save it. And in order to do that, we're going to hit Control-X. And it's going to ask us to save the modified buffer. We're going to hit Y for yes, and then we're going to need to name it something. So for this configuration, we're going to name it memoryfix.sh. And once we have that entered, we'll just hit enter on the keyboard. And this will bark us back to the command line itself on the server. So now if we do ls and hit enter, we're going to see memoryfix.sh, but we're not done yet. We need to do chmod. We need to do +x. Then we have to type in mem and then hit tab. What this is going to do is it's going to modify the file and give us permission to execute it, which is the +x. And in order to finalize the command, we're just going to hit enter. Now if you hit ls on the keyboard, you'll see that the file color has changed. This indicates that the file can now be executed. To execute the file, we're simply going to type in sudo space bash space memoryfix.sh and hit enter. If prompted, enter your credentials for the server to continue. Once the script finishes, you will not require a reboot to continue. The script has the baked-in configuration that restarts the service itself, so you do not have to restart your server. The next portion of this is we're going to install the Ollama software itself. Once again, we're going to type in nano and hit enter. Since I like to do everything in a script-based format, I've chosen to use a script. However, you can just grab the single line and do the Ollama installation this way. Note that you can visit the actual website and grab the SH file and modify it. However, you cannot modify the location in which the LLMs are stored. The reason being is they are stored in a location that has the utmost performance in mind. So modifying the configuration to change where the LLMs are stored will reduce the performance of your system. And if you're not starting out with a system that was $100,000, you don't want to reduce the performance. Once you have the data entered, once again, we're going to hit Control X. We're going to choose to save the buffer, and we're going to name it ollama.sh and hit enter. Once again, we're going to have to do a chmod +x, and we're going to have to change the Ollama configuration and then hit enter. Now we're going to enter in the command sudo space bash space ollama.sh and hit enter. This configuration may take some time to complete. At this point, my installation is completed. You'll note that I do have a warning that no NVIDIA or AMD GPU were detected. On this particular system, again, I'm on a VM, but keep in mind that if you get this and you do have a video card, make sure that you go through the video card graphic driver installation again, because it's possible that sometimes during the installation process, it could even rewrite or revert the actual driver configuration and cause an issue. At this point, after this has been installed, I would suggest you do a reboot, even though it's not called for one, just because it's going to clear stuff up. And then once it comes back up, we'll run another sudo apt update. And if there's any packages available for upgrade, we'll do that, and then again, reboot. So basically, all you're going to type in is sudo reboot now and hit enter. Once the server is back up, you're just going to type in sudo apt update and then hit enter. If you're prompted, enter your password and hit enter again. We can see on my installation, I have 12 packages available for upgrade, so we're going to do the upgrade and then a reboot. So once again, that's just sudo apt upgrade space -y and space sudo reboot now and then hit enter. Now that the server's been upgraded, updated, it has the AI package, the Ollama package installed, we have the memory allocation configured, we have the video card configured, we are up and running. At this point, we could theoretically just download an LLM and run it right through the actual terminal. However, for the sake of this video and the ease of access in the future, we're going to install a web portal front end. We're also going to modify the configuration to include firewall settings, which are kind of important when you're configuring AI because there is an API that runs on a port. And for our system, since we're going to run this offline, there's really no reason for us to have that API at all. So what we're going to do is we're going to now modify another script with nano. And once we get that set, we'll do our change mod again, make it executable, and then we'll run the command on it. And once it finishes, we'll have to log back into the system again, and then we'll have to install our LLM. Now, once our LLM is installed, that means we could go to a GUI web page off of our Linux Mint system and actually launch it and start to ask it questions, much like you would on ChatGPT. So let's kick off this final portion. We'll start with changing directory to our scripts folder. We'll do ls again, just to see what we got in there. Then we're just going to type in nano and hit enter. Well, once again, copy stuff from our clipboard, and we'll paste it in. And once we do that, we're going to see that we have a full configuration in here. And what this is going to do is it's going to create a custom port of 8143 for an HTTPS website that we can access. Then it's going to configure our directory structure for our ability to actually run Python. We're going to create a Python container and do this the right way on our configuration. And then we're going to modify our firewall to allow 8143 TCP and port 22 so we can continue our SSH connection. And then at the end, it will finalize, but we will have to reboot after this finishes. So as always, we'll hit Control X. We'll say yes to save the buffer. And we'll name it webgui.sh. And then we'll hit enter. And we're going to have to change the configuration to make it executable for the webgui.sh file. And then we're going to hit enter. Now, this is where it changes slightly, because in the previous commands, we've done sudo bash and then the actual file. But for this, we're just going to do bash and then the file name. The reason for that is because we're going to use Python configuration, and you don't want to run sudo commands on Python to create your container. You want it to run with as little permission as possible, so that way you can keep your infrastructure secure. And since the commands are baked, where if it's apt-based, it has the sudo command in the script, it's not necessary to run the sudo command against the file. It'll actually run it in the script itself if it's required, but if it's Python-based, it will not, so that way it keeps it secure. Once I hit enter, it's likely still going to prompt me for the requirement to run the password to run things as sudo, but that's just because of the sudo commands that exist within the file. So let's just hit enter, and there we go. So we'll enter our password now, and then hit enter. This script will take a while to run. Okay guys, so for those of you who are still with me, we've got the server now configured. The next thing we have to do is actually install the LLM. And in order to do that, I have the commands listed on the screen, as well as the size of the file and the amount of billions of actual lines of code of language. Since the vast majority of you are probably watching this on hardware that's similar to my own hardware or slower, then you're probably going to want to stick on the low-end machine and maybe the mid-grade. Maybe. Let's start with it in an easy way. If you're running Windows 11, chances are you have the ability to run this in some form. I would say that your likelihood of actually being able to run these is fairly high. It gets a little more questionable when you get down into here, because now we're talking about text and images. And then when we get down further into somewhere in here, now we're talking about somebody that has a full-on gaming machine. And then finally, if we scroll down towards the bottom, we're talking about somebody that has a massive server with a ton of video cards, a ton of resources, and likely a ton of money. The most similar to something like ChatGPT is going to be right here. So for the sake of our install, that's what I'm going to use. I'm going to use the open chat model, and that is specifically the command ollama pull openchat:7b. Now, if we're back at our terminal here, what that means is we're going to just have to simply type in or paste in the actual command, which is just ollama pull openchat:b, and then hit enter. Even if you have a really fast internet connection, don't expect blazing fast download speeds on this. For anybody that's ever done a file migration, you know that if you have one file that's 200 gigs versus 200,000 files that's 200 gigs, the one file takes a lot faster to download. Think of this as the latter. We're talking about a ton of different lines of code inside of a container. In that kind of instance, you're looking at it more like a zip file or a RAR file that you're downloading. I do want to add this little piece here where if you go to launch the actual web portal and you get this error that you can't find the actual site, and you're absolutely confident that you have the right IP address, you have the correct :8143 that's baked into the script for the port number, and you still can't access it, there's a strong possibility the web portal is just simply not running. To start with, SSH back into your server. And rather than spending a whole bunch of time troubleshooting the web configuration, let's make sure it's running first. To do that, simply type in systemctl space -- user space daemon - reload and hit enter. Next, run the command systemctl space -- user space enable space -- now space open webgui.service and hit enter. Now go back over to your web portal and hit enter on the actual search bar, and let's see if this fixes the issue. It did fix the issue, but my issue was actually with my browser. So I'm using Chromium and not Chrome. And as a result, it doesn't like the fact that I'm not using a signed certificate to get into the actual website for AI. So I had to make an adjustment to the actual browser to get back in. However, those two commands will restart the actual service for the web portal, so that way you can log in if there is an issue. So let's get this configured. What we're going to do now is just click on the Get Started. And we're going to have to put in a name, an email address, and a password. The email address could be anything you want to make it because it doesn't matter. The server has no access to the internet, so it's not sending emails to anybody. All it's going to do is it's going to configure whatever that email address is as your username when you attempt to log in and greet you with your name when you're logged in. Also, keep in mind that the password should be something obscure and not the same password you log into the server with. Once you have your data entered, just click on the Create Admin Account. At this point, it's going to tell you about what's new in the Open Web GUI. We'll just say, okay, let's go. And here we go. So now we have to select a model, and we could see that our OpenChat 7B model is in here. So we could select that. And at this point, now we could ask it something just like we would in ChatGPT. So we could ask it something simple like, can you tell me about the game of checkers? And then hit the send message. And as you can see, it's filling out the details and the information. You could even start having fun with it like you did in your ChatGPT configuration online, where you could start to ask it things like, all right, well, can you explain checkers the board game, but if you were a pirate under attack? So guys, this concludes video 1. Video 2 will have more information on how to do the configuration on the GUI side. You can look for that video next week. Let me know down in the comments if you run into any issues. Alternatively, let me know down in the comments if you enjoyed this project. Thanks guys for watching, and I'll see you on the next one. Thank you for watching the Generic Tech Support YouTube channel. Find the content of this video at https://generictechsupport.com/channel.